All right, today we're going to look at 7.4. We're going to look at different properties of quadrilaterals. Today we're going to recognize the special properties of parallelograms. So we're going to look at a rhombus, a square, and a rectangle. And then we're going to need, you can look at this Venn diagram, and then another way to look at this is this flowchart of how the properties are. So we're going to have the quad at the top, and then we have three different types with the kite, parallelogram, and trap, and then we can get more specific. We're going to be looking in today with the different types of parallelograms. So we could have a rhombus, a rectangle, and then the most specific one, a square. First off, looking at a rectangle, we need to remember that a rectangle is first off going to have all of the properties of a parallelogram, plus it's also going to have all angles are right angles, and then also diagonals are congruent to each other. Some properties of a rhombus. First off, remembering that, yes, it is, again, all properties of a parallelogram. And then some specific properties for a rhombus are all of the sides are going to be congruent. Diagonals are going to bisect the angles. So all of four of those angles would be congruent, and then same thing on the other diagonal as well. Also, the diagonals are going to be perpendicular bisectors of each other. And then another diagonal property are that the diagonals divide the rhombus into four congruent right triangles, and that's because of the perpendicular bisectors. And then in a square, again, all properties of a parallelogram, and then also because of it coming from a rhombus and a rectangle, it's going to have all rhombus and rectangle properties. Oops. And the diagonals form four congruent isosceles right triangles. So we can use these properties to solve some algebra, understand some sometimes always never's questions, etc. So first off, for any rectangle ABCD, decide whether the statement is always or sometimes true. Label the rectangle A, B, C, and D. If for this first one I say that AB is congruent to BC, that would be sometimes true, because that would only be true if the rectangle was actually a square. And then when would AB be congruent to CD? That would be always true, because those would be opposite sides, and they are always congruent in a rectangle. For the one on the right, classify the special quadrilateral, explain your reasoning. So looking at the markings, I could see that because both pairs of opposite sides are parallel, that would tell me that it's a parallelogram. But then it also has the congruent sides there. So, and we have consecutive sides congruent, which makes it a rhombus. We can apply these into our proofs as well. So first off, looking at the fact that rhombus ABCD is given, we could, in this one, rhombus ABCD is given. First, we could say that opposite sides are going to be parallel. So we could say that AD is parallel to BC. and a rhombus tells me that opposite sides are parallel. We could also say that DE is congruent to EB because a rhombus implies that diagonals bisect each other. With parallel lines on the top and the bottom there. I'm sorry, not the top and the bottom. Although those would also be parallel. We said the ones on the left and the right. We could say because of alternate interior angles, that angles 1 and angles 2 are congruent to each other, and parallel lines imply the alternate interior angles are congruent. Next thing we're going to do is look at the perpendicular things, which are actually marked in the diagram as well, because we're going to have the right angles there. So we will say that EG is perpendicular to CB, as well as EF is perpendicular to AD. And I'll label those angles 3 and 4. The first one would imply that angle 4 is a right angle. And then the other one would imply that angle 3 is a right angle. So getting all of these marked are given and are given. 7 and 8 are both right angles because perpendicular implies right angle. And then we also know that they would be congruent because right angles are congruent. And then given the fact that we now have in this triangle here, we have 2 angles marked congruent and a side. So we could say that triangle DEF is congruent to triangle BEG by angle, angle, side. And then EF is congruent to EG because of CPCTC. We could also solve for some algebra questions here within our properties. So using this diagram for all 4 of these, if ST was 13, then how long is SQ? Because the diagonals are bisecting each other, we would know that SQ is 26. If PRS is 17, then how long is QRS? Bisecting the angles would make it 34 degrees. STR has to be 90 because the diagonals are perpendicular to each other. And SP is congruent to SPPQ because rhombus implies that all sides are congruent to each other. And so we get X equals 7. Go ahead and take a minute to solve these 5 questions right here. And because of the right triangle here, we'll get 31. Perpendicular diagonals. Diagonals bisect each other, so we'll get 24. Bisecting the angles, so I'll get 59. And AD would also equal 14. Now looking at a square, go ahead and pause and solve for these 5 as well. In a square, AEB would be right there perpendicular, so 3x equals 90, so x equals 30. BAC, because it's a right angle and diagonals bisect, that angle has to equal 45, so x equals 5. For number 3, the sides have to be equal to each other. So I'm going to get x equals 9, which means BC is equal to 22. DAC is half of the right angle, so it's 45. And BAC is also equal to 45, so x equals 15. AB and BC are both sides, so sides of the squares are equal to each other. Set them equal to each other. And then we get to factor here. And we get 2 answers for x on the bottom there, which are 5 and -3. But it cannot, in this case, equal a negative x value because it would give us a negative side value. Now looking at the properties of a rectangle. So again, go ahead and pause and solve for the properties of a rectangle. AC and BD are both diagonals, so they need to be set equal to each other. And you're going to get x equals 18, which means that BD equals 12. AC is the entire diagonal. AE is half of the diagonal, so I need to multiply AE by 2 in order to get AC. And I'll get x equals 35. And when I plug that in, I'll get EC equals 40. Same thing here for 3, 4, and 5, finishing up with a rectangle. BAC and CAD together would form the right angle, so I need to add them up and set it equal to 90. I would get x equals 11, and then when I plug that in, I'll get CAD is 41. AE and BE, well, the diagonals bisect each other and they are congruent. So those two pieces would be equal to each other. So 2x plus 3 equals 12 minus x, which is x equals 3. And then I get that BD equals 18. And then for number 5, looking at angle BAC and ACD, they're alternate interior angles, so they would be congruent to each other. Which means x equals 7, and then the measure of angle AED equals 52 degrees. Lastly, need to draw this triangle in the coordinate plane and find slopes or distances. Come up with the all of the names that would qualify and what is the most descriptive name for this one. Go ahead and finish this one on your own.